Okay, so now we come across a topic which may seem like it just comes out of nowhere. Carbon atoms with formal charges. Carbon atoms with formal charges. The reason we care about this is because carbon atoms with formal charges is going to be a key factor in many of the things that we have to learn in the future. So this is a big deal, and it's going to help you a lot if you can get used to carbon atoms with formal charges. We have one major question, one overarching question in organic chemistry. And this is going to surprise you how simple it is. We have one question that we're typically trying to answer, and that is, what are the electrons going to do? Oops, wasn't supposed to say the word. What are the electrons going to do? Okay? Now, that probably seems like that's coming out of nowhere. What are you talking about, the electrons? We care about carbon atoms. We care about bonds. We care about nitrogen and hydrogen and carbohydrates, right? Well, it turns out that central to the story almost always is, what are the electrons going to do? And the way we're going to predict what the electrons are going to do, the way you're going to think like an electron, is you're going to first of all understand shape. That is the shape of a molecule, not the shape of an electron, right? You're going to understand the shape of molecules, and we're going to understand the electron density of molecules, okay, or ions, right? So if you know where the electrons are and where they're strongest, you know what the electrons are going to do, because electrons are attracted to positive charges, right? And so that is what organic chemistry is all about. Now, since we're determined to get used to carbon atoms with formal charges, right, we're going to get our eyes used to a couple shapes. Number one, can you see a carbon atom here with 3 bonds and a plus charge, right? We're going to call this a carbocation. Look at this. Get your eyes used to it. We're going to call this a carbocation, okay? And we're going to get used to a carbon atom with 3 bonds and a plus charge. That's a carbocation. This is very central to many of the stories that we tell in organic chemistry. All right? And another structure which is not as central is this structure, and this is a carbanion, a carbanion, okay? So I've got a carbocation and a carbanion. This has got a carbon with 3 bonds and a lone pair of electrons, and that has a formal charge of -1. Now, you don't have to memorize that it has got a plus and a minus. I'm only telling you that it's going to make your life easier if you recognize that. It immediately becomes obvious that you have a carbocation if you've got 3 bonds and no lone pair of electrons, or 3 bonds and a lone pair. If you know that that's where the electrons are, or that's where the electrons are not, in this case, right? We've got a hole here, and this is trigonoplanar, right? It's trigonoplanar, which makes it a good attack site for electrons. Super central to many of the stories we tell in organic chemistry. So get your eyes used to looking at this. Now, we're going to stop and say to ourselves, all right, so here's what I'm memorizing. If I've got 3 bonds and 0 lone pairs, I have a formal charge of +1. If I have 4 bonds and 0 lone pairs, it's neutral, right? That's what I'm used to looking at, right? That's just like methane. Almost always, carbon has 4 bonds, right? I say almost always. When it doesn't, then it's some kind of an important story being told, right? Now, carbon never has 5 bonds, in case you think I'm going in that direction, but sometimes it has 3 bonds and a lone pair, 1 lone pair of electrons. And in that case, it has a formal charge of -1. All right? So I wouldn't memorize this table. I would get used to, if I were you, I'd go back to these structures here and get used to looking at that. That's a carbocation, and it's a big deal. This is very reactive. Whenever you see this in organic chemistry, this is the center of the story, okay? Or whenever you see a carbanion in organic chemistry, that's the center of the story, right? So if you get your eyes used to looking at these, you're going to be able to see past a lot of the unimportant details, and you'll see right to the heart of the story. I told you once before that I did okay. I got an A in Organic 1 by the skin of my teeth. But in Organic 2, I was just killing it. And the reason is because I saw the simple behind all of the details. Okay? So let's go back here now. If you have a carbon that has 3 bonds and 0 lone pairs has a +1 charge, you prove it to yourself. Do the formal charge calculation. 3 bonds and 1 lone pair, it's a -1 charge. And I think the next thing I'd encourage you to do is ask yourself, what about oxygen? How many bonds does oxygen like to have? What happens if I have an oxygen with 2 bonds and 2 lone pairs? What's the formal charge going to be on that? It looks like water, doesn't it? What if I have an oxygen with 3 bonds and 1 lone pair, right? This is a common thing we see in organic chemistry. And if you get used to putting a little sticker on there immediately because you're used to it, then you've got yourself an immediate hint about what's going to happen, right? Next question, what about nitrogen? I'm going to leave you with that. Carbon atoms with formal charges, big deal. I hope you like it.